Alright guys, so today we're going to be learning about electrical circuits and how electricity is able to travel through them. So, the first thing that I want to ask you guys is, what do you already know about electricity? Raise your hand when you have an answer. Kaylee?
It has a positive and non-positive charge.
So Kaylee knows that it has a positive and a negative charge. So Kaylee's going to write her answer on the Post-it and go add it to the anchor chart. James, what do you know about electricity?
I know that electricity powers most of the stuff that is in life, like phones, lights, TV.
So James knows that electricity powers a lot of the stuff that we use in our daily lives. So he's going to write that and add it to the board. Moeda?
It's something that works through wires.
So Moeda knows that electricity works through wires. Kaden?
Electricity is produced by a power source.
I really like what Kaden just said. Can you repeat that louder?
Electricity is produced
Kaden said that electricity is produced by a power source. That's awesome. Write that on the Post-it and go add it up there. Cameron?
sometimes you can't see it.
Sometimes you can't see it. That's true. Solana?
And it's down because it's down, but it doesn't have any versions.
Tyler?
Saying like you need to power up something, energy used like electric. It's used like what I just said, positive and neutral.
Okay, so first Tyler says that it used energy. So I want you to write that on here. It uses energy. Tanisha?
Electrical energy.
Electrical energy is an energy. Isabella?
That sometimes energy can be a need, but it can also be a want.
That's exactly right. Lola?
Electricity is energy, and it's called light energy.
Okay, you write that on here and go add it to the board. I'm going to take one more. Clover?
Electricity has different types of energies.
Okay, you write that and you're going to add it up there. So you guys already know a lot about electricity. So I've got a challenge for you guys. You're going to see materials on your desk. There's going to be light bulbs, wires, and batteries. My challenge to you guys is I want you to use those materials to light the bulb. Those are your only instructions. Go ahead, work with your groups. I like that you guys are connecting something. So, when you jump on, you don't know how to jump. Wait, wait, I don't Where can we connect it? So the block is a negative, so where can we put that? It's okay, baby, it's a power source.
This is scary. I feel like I'm gonna I knew it. Oh, that's cute. Alright, so one came off. Yeah, you're doing it.
Because I like that you guys have stuff connected. Is this one connected?
This is what we do. Oh, nobody's talking about it. Yeah. This is the negative.
So now how are you?
Yeah, but you have to attach this one to the battery.
So now how are you?
So then the battery is the light bulb. It should take a while. Wait, let me look at this.
I liked that idea.
Wait. Wait, let me try to do positive. You told positive. Other way. Yeah, we did it. battery out of battery. You see this? Minus and plus.
That's
Minus and plus.
And what do you notice about this circuit?
they're sending electricity.
Do we get worse?
We did it the other way. Minus and plus. Positive and
Explain to him how you do that.
Wait, can I try something I haven't done anything? I'll make a bunch. It should be block. It should be
Like basically when we jump right.
shoot it. Black and
So
minus.
what happened? Control it.
Yeah, black is minus. How do you
This is
get it out?
over here. This is there. So I can take that.
What we have to put on this one side is minus.
I take this one.
So you touch it right so that it's all the way to here. There you go. Good job.
Still don't know.
Okay, so I want eyes on me.
This one doesn't do anything.
Okay, eyes on me, guys. Drop your circuits. Eyes on me. If you were able to light your bulb, drop your circuits. If you were able to light your bulb, I want you to raise your hand and you're gonna describe to me what your circuit looks like. Jacob?
The circuits are they're inside like a tube so that you don't get
Okay, so start by telling me what you have. So start with your battery.
my battery's inside this tiny box with no cover. And it
Okay,
has,
so he's got his battery. What's connected to your battery, Jacob?
these wires, like these cling things. I forgot what they're called.
Okay, so did it matter where your red wire was connected to, Jacob?
Yes.
Where was it connected to?
It was connected to the blue box with the battery inside.
Okay, so his red wire is connected to his battery. And then what is your red wire connected to after that?
It's connected to this metal to make the light bulb.
Okay, so then it's connected to his light bulb.
And then the black one is the negative side. It's also connected to the blue box with the battery inside. And it's also connected to the blue platform to make the light bulb flow.
Okay, so if you were able to light your light bulb, did you have something similar to this?
Yes.
What do we notice about that? Daniel?
Basically, you know how you jump a car?
Mm-hmm.
Use cables. They're called trucker cables. You put them on to your piece of the car that has better one, and it makes like specific pieces. So if you just take one piece off, it messes everything up. So
Repeat that part one more time. Everybody listen. When you take it off, what happens?
if you have it on, it's lit, right? It helps it jump. If you take one piece off, just one piece, it's all gone.
So when everything is connected, our electricity is able to flow. As soon as we disconnect one of our wires, our electricity is no longer flowing. So everything has to be connected. And that, guys, is called a closed circuit. So whenever you take one of the wires off, not everything's connected, and now that's an open circuit. So our electricity is only able to flow when we have a closed circuit. So I'm gonna give you guys one more minute. If you weren't able to light it the first time, you've got one more minute to light it.
Let's restart
You said I do, you guys do
Yeah, but you can use it like this. You can use it like this.
It's not.
you can just because you connect the side nose, like you connect into the back of the car.
You know when you said everything is
The class before you might have had it plugged into it, so let me put you in the light.
We know our plus and our minus. The plus, I know.
You do it first. You do it.
What happens if we do it reverse?
Try this one.
What if I put the red on the negative?
Don't fight over it. You only got 1 minute.
Looks like a candle.
Miss Hopecamp. Negative side, it doesn't work.
I like that.
This is a night light for babies. You got little babies in it.
Oh, like this is it.
No, it doesn't fit there. Let's put it closer so it fits.
I do have a
This one doesn't work then.
Oh no.
Alright guys, bring it back.
No, you cannot.
Thank you. Bring it back. Okay, so while we were exploring, Jacob's group noticed something about where they were placing the wires. Isabella, what did your table notice?
We noticed that if you put the negative side on the non-negative side, or positive side, it still works barely.
Okay, so Isabella's group noticed that it didn't matter which side your wires were connected to, it would still light the bulb. Alright guys, so can you please disconnect all of your wires and place your materials in the middle of your table? Whenever your table's ready for the next activity, give me a thumbs up. James's table's ready. Jacob's table's ready. Ethan's table's ready. Solana's table's ready. Alright, almost everyone's ready. There we go. Okay, so I'm gonna tell you guys as a table to stand up and we're gonna, no. As a table, I will call on you. And we're gonna stand up and we're gonna make a circle around the room. So you need to be on the outsides of all the tables. So, Ethan's table, you can start. This table, you can start. James. On the outside. Haley's table, you guys go back there. You guys come up here. And you guys make that work. Okay, so. Listen, already. Okay, so I'm gonna hand everybody a piece of the rope, and what I need you to do is hold the rope still as you can. Let's try and see if we can hold it without moving it. So grab a piece whenever it comes around to you.
No, Tyler gets the end. The end of the end.
Okay, so right now, everybody has a piece of the rope and it's going all the way around the room. What could this represent?
A wire.
Raise your hand.
Electricity.
Raise your hand when you think you have an answer. Tanisha, what could this
It
represent?
looks like a wire on the power line going
Okay, but we have it going all the way around. And it's connected right here. So what could this represent?
Electricity.
Kaden.
This could represent like
Hold it still.
lights.
So right now, this represents our circuit. Listen. This represents our circuit. Hold it together, Tyler, so that we have a closed circuit. Hold the two pieces of the rope together so we have a closed circuit. There we go. So right now, our rope shouldn't be moving. Why is it not moving, Daniel?
Because we're holding on to it and we're making.
But remember, this represents our circuit. So why right now is nothing moving? Kinley? Okay, so let's think back to our circuits. Who thinks they know what was happening inside of our circuits? Kaden, what do you think was happening inside of our circuits when we were here at the table with our wires?
Electricity was going through the power.
So Kaden thinks that electricity was going through the wires?
Yes.
Where did the electricity come from,
The
Kaden?
battery and
Okay, Kaden thinks that our electricity is coming through our battery. Raise one hand if you agree with Kaden that our electricity is coming from this battery. Does anybody have a different idea of where our electricity is coming from? Nobody?
Nope.
So,
no, the wires. It's coming from the wires.
our electricity is coming from particles
Yeah.
in the wire called electrons. Listen, because you need to know this. The electrons exist in the wire. When we connect them to the battery, then what happens, Kaden? Isabella?
Electricity travels.
The electrons are able to travel when we connect them to a power source like a battery. So right now, we do not have a battery, which is why our rope is completely still. So, if I add a power source, what will happen to our rope?
It would move. The electricity would travel through the rope.
Electricity will travel through the rope. So, whenever I connect our power source, then you guys are going to gently rock the rope. Don't do it yet because we don't have a power source yet. So right now it's completely still. So now we have a battery and you're going to gently shake it. Why is our wire moving now? Why is our circuit moving? Raise your hand. Raise your hand. Chelsea, why is our circuit moving now?
Because we have a source to connect it to.
We have a power source, and the electrons are flowing through the circuit. If I remove our power source, what's going to happen? Here.
Cameron, stop.
If I remove the power source, Cameron, what's going to happen?
It's not gonna move.
It's not going to move. What if I add the power source over here? And what if I
It's
remove
still
it?
going to move slowly though.
Stop moving it.
So now, what if I have a power source and a light bulb?
It started lighting.
Boom!
It's not light.
Okay. So
Actually,
Connor says it will light.
no, it won't.
So Connor will be our light bulb.
Can I be better?
And Tanisha will be our power source. So Connor,
Good battery.
whenever we add the power source, Connor, I want you to hold one hand up and shake it. And that's going to represent that our light bulb is lit up. And our rope is going because why?
Stop.
So
Don't
when
we still keep going because
no, but we have a light bulb and no power source.
That's like
Listen,
making a
because
lamp.
this is your question. We have no power source, so that's why our movement stopped. The electrons cannot flow without a power source. So I want everybody to drop their rope
Tyler, that includes
and return to your desk.
drop it like it's hot. Why did you do that?
All right, so I have a question for you guys. I have a question. So we have the electrons that exist in our wires. The wires need to be connected to something in order to light the bulb. What is that something they need to be connected to? Aiden? A battery or what?
Power source.
Some type of power source. So my next question for you guys is, how do you think that the size of wires affects the flow of electricity? Think about that in your head for a second. How would the electrons in this wire compare to something like this that's powering our laptop cart? Look at the difference in the size of these wires. Think about it. We're not going to share yet. We're just going to think about this. So to demonstrate this, I need 2 people that think that they can drink Gatorade faster than anybody else in this room.
Oh, really?
And if you're up like that, I will not pick you. Let's do Tyler. And let's do Tanisha. Okay, so I have already poured. Listen. So I have poured 150 milliliters into each of these beakers, and I'm going to pour them into our cup. Tanisha, come around to this side. Yes, sir. They won't.
What if it accidentally spills? Who cares?
Okay, so stand on this side of the table. And this is going to be a race to see who can drink Gatorade the fastest.
Don't spill it.
You know how to drink. All right. So, grab your cups. 1, 2. Wait. How does this represent wire size? How can we fix that? So how is this? How would this change the results of them drinking the cup? Just think about it. We're going to watch it first. So Tanisha's going to get this size straw. And Tyler's going to get this size straw. So listen, I want you guys to think of these as wires. So this is going to be a bigger wire, like that is connecting our laptop cart. And this is going to be a smaller wire, like how we have on our desks. All right. For real this time. On the count of 3. 1, 2, 3, go.
Drink. Look at Tyler.
Yeah, because the chalk is big, like much more.
All right, stop.
Tyler, you still have to get right now.
All right, you guys can return to your seats and sit down.
Oh my God.
Give me 5 when you're ready for my question. So, what happened?
Tanisha won.
Raise your hand. Connor, why did Tanisha win?
Because the big one holds more
one can allow more Gatorade to pass through than the small straw. Cameron, how does that have to do with wires? Okay, but think about this as our wire that's powering our laptop part and our wire that powered our bulb, our light bulb. What's the difference, Kaden?
You should say what's the same.
How does that wire size differ from this wire size?
Because
Think of it like the straws.
that wire it has is big, so it has more space for the electricity to pass.
It allows more electrons to pass through more quickly. So something with a thicker wire like that holds more power than something smaller like this. Alright, so I need everyone to get their science journal. If you're at this table, go first.
Get your fire bid with you, can you take it? Leave your bid on the floor. Leave your bid on the floor.
Ethan's table, go get your science journal.
Anyway, good job. You finished more than half of it, I think.
It's actually
Lowena's table, get your science journal. You need your science journal out. But remember, which table hasn't gotten their science journal yet? Okay, go guys.
How do I know? I saw
Alright, give me 5. Give me 5. Cameron. Okay, so today we learned about how electricity flows through a circuit. What kind of circuit do we need, Daniel? We need an electrical circuit. Is our circuit going to be open or closed? Hang on. Let Daniel take this question. Okay, I need everybody's eyes on the speaker. Go ahead, say it again. So if we have an open circuit, then what happens?
If you have an open circuit, the electricity goes every which way, and if you plug it in and you're right, you can electrocute.
Okay, so whenever our circuit is closed, the electrons can flow all through the circuit. When our circuit is open, nothing happens because they're not connected to a power source, and that's why they're not moving. The battery or the power source holds stored potential energy. So that potential energy has the potential to send electrons flowing through the circuit. That's why we need the battery. That's where our power comes from. So in your science journal, you are going to answer these 4 questions. And this is independent work, so do not work with your table mates. This is just for you. don't have to write the question, just the answer.
Can you see anything? You can't see, move up, right?
So number 4 is basically asking you to draw a model of what we created with the battery and the wires and the light bulbs.